Very warm greetings to everyone and welcome to the 10th Surpac tutorial where we get to learn basic statistics of drill-hole data. For your good, I recommend that you go through the previous lessons in order to understand this particular tutorial and the subsequent lessons to come. This is because this particular lesson seems the turning point of our journey. All along these tutorials, we've been wanting to get to a point where we will be able to create a block model and estimate the resource by means of geostatistics. So if you're watching this video, all you need to do is to listen attentively and follow everything that I'll do on the screen. So let's get started. Basic statistics. As part of the preliminary steps in performing geostatistical evaluation, it is important to understand the statistical properties of the data. And the question is, why is it important to understand the statistical properties of the data? The purpose of getting to know the statistical properties of your data is to help you to know, understand, and deal with all potential factors that may affect your estimation. There are two characteristics or properties which can potentially reduce the quality of your estimations, and these are bimodal distributions and outliers. With the help of a histogram, these two characteristics, bimodal distribution and outliers, can be identified. If you take a look at my work directory, basic statistics, I have three folders here, namely bimodal distribution, histogram, and outliers. Bimodal distribution and outliers are the two characteristics or properties which can potentially reduce the quality of our estimations, and the histogram is used to identify the two factors or characteristics. Okay, so I'll explain them one after the other. I'll begin with histogram. I'm pretty sure most of you are familiar with histogram in elementary school or high school. If not, I do have some images that will be displayed so that you get a clearer understanding. I'll start with histogram. A histogram in statistics is a type of graph which allows a visual interpretation of numeric data by indicating the number of data points that lie within a range of values called class or bin, or a series of intervals. So let's take a look at these images. This is a typical histogram. As you can see, a histogram employs bars in analyzing data. So the higher the bar, the higher the frequency, and the lower the bar, the lower the frequency. Okay, these are also histograms. This is a typical histogram with a frequency polygon curve passing through the midpoint of each bar. You can also have a histogram with a normal distribution curve as shown on the screen. Okay, so I'll move to bimodal distribution. As the name implies, it is derived from the word mode. The mode of a dataset is the most occurring value in the data. Where there is one or single mode, we say there is unimodal distribution. Unlike a situation where we have two modes, we say there is bimodal distribution of the dataset. So in statistics, bimodal distribution refers to two relatively most common values which are not adjacent to one another. Let me bring these images so that we will understand what I'm talking about. Okay, this is a typical bimodal distribution which is identified by a histogram. Any histogram which displays two peaks or humps is said to have bimodal distribution. That is, two bars at their peaks that are not adjacent to one another is said to have bimodal distribution. If you take a look at this graph here, we can see two bars at their peaks that are not adjacent to one another, and this is said to have bimodal distribution. If you take a look at this bar, it's occurring at, let's say, 5, and this one is occurring at 25. So 5 is quite distant from 25. These two bars that are occurring at their peaks is an indication of bimodal distribution or bimodalism. This is also a typical histogram and a normal distribution curve. The normal distribution curve is being displayed as humps here, or two peaks. So this is a typical bimodal distribution. Most often than not, the source of bimodal distribution is a mixture of two domains into a single dataset For example, if you go into the field to collect data from two different concessions and maybe you want to determine the average grade of soil samples, you don't have to mix the samples collected from the different concessions together. Otherwise, there is a likelihood of getting bimodal distribution that will affect the average grade that you want to estimate. It is recommended that you separate or segregate the data so that you analyze them separately. You determine the average grade of the samples collected differently from the concessions. Okay, so I'll move on to outliers. Outliers are data values that are much higher or lower than most data values in a single domain. In statistics, an outlier is a value which is significantly or relatively distant from the majority of all other values in the dataset. So we take a look at some images here. This is a typical outlier which is determined by a histogram. If you see a bar or a value that is quite distant from the rest of the bars or the population data, then you can identify the isolated value or point or bar as an outlier. As you can see, this bar here is isolated from the rest of the data and it can be identified as an outlier. With regards to scatter diagram, you notice that outliers are falling way beyond the rest of the data set. Okay, this is also an outlier. And we have a histogram and a scatter diagram here. The green one here is indicated as an outlier and the red for the scatter diagram here is indicated as the outliers. Okay, outliers can cause problems with variogram calculations and block model estimations and can lead to unrealistic or misleading results. So there should be an attempt to always eliminate outliers, and it can be eliminated by applying a cutoff or totally removing them. Alright, so now that we know and understand the terms bimodal distribution, histogram, and outliers, we will focus on creating a histogram so that we will know if there is bimodal distribution or outliers associated with our data set. Remember, the statistics is to be done on the data in the database. So we will head over to database, go to analysis and select basic statistics window. Another way of opening this window is to go to block model, geostatistics, basic statistics window. Is the same thing. Okay, then from here the first thing that I will do is to load my string file, that is the composite. If you take a look at my rec directory basic statistics, I also have the composite inside file here. Composites are created from sample values and the first description for D1 of the composite contains the good values. So that is what we are going to perform the statistics on. So I'll go back to database, analysis, basic statistics window. Then the first thing I will do is to go to file, load data from string files, or I can use this icon here which says load data from a string file. I'll click on it and this mini basic statistics window will appear. As you can see, we have two tabs here, basic and advanced. I'll explain whatever that is indicated here. Location, the location is the file, specifically the composite file that you want to perform the statistics on. So you go into your rec directory and select it. ID range and string ranges are all numbers that are associated with the file that you will nominate here. Description fields for data, default. The default here is D1 because the composite file contains good values in the first description field or description field 1. That is why D1 has been chosen as the default. Name. Here you can assign a name to the nominated description field for meaningful display. The D1 in the composite indicates the good values or the assay values. So if you want the name to be displayed, you can enter that here. Minimum value. The minimum value here refers to the lower limit constraint. Samples with values which are below the value that will be entered here will be neglected or disregarded. The same thing goes with the maximum value. This is the upper limit constraint. Samples with values which are above value that will be entered here will be ignored or disregarded. If you do not want to apply any minimum and maximum constraint to your data set, you can leave these fields unfilled or you can leave them blank. Histogram bins number. The number here refers to the classes or the bars on the x-axis. That is the number of bars that will be displayed on the x-axis. And the width refers to the thickness of the bar. We will create histograms with different number and width so that you get to appreciate what I'm talking about. Then I come to include coordinate graphs. If you want to create graphs of the x, y, and z coordinates, then you have to check this box. I move over to the advanced tab where it says graphical constraints. As the name implies, graphical constraint, you want to constrain your data by means of location, or you want to constrain your data geographically. So minimum and maximum values are here. Samples which have their x, y, and z coordinates that are less than the values that will be entered here will be neglected. So these are the minimum values for the location. Samples that have their x, y, and z coordinates greater than the value that will be nominated here will be neglected. So this is constraining your data by means of location or coordinates. Alright, then I come to treat negatives as. There are three ways in which negative samples can be treated. They can be treated as zeros, undefined, or negatives. If you select zeros, it means that samples with negative values will be assigned a value of 0. Undefined means that samples will be disregarded. Negatives means negative samples will be maintained. Okay, so now that we understand what is on these two tabs, let's go ahead and fill it up. I'll go into my rec directory, then I'll select composite. The composite is what contains the good values, so I will select that. Then the description field is description field 1, D1. That is what contains my good values. And I can enter a text here to represent the name just for meaningful display. I will enter here gold. I don't want to apply any minimum and maximum constraint values to my dataset, so I'll leave this fields blank. Histogram bins, usually you use the width. Okay, we will create a histogram with first 20 number of bins, then we'll come back and change it so that you understand it. Let's maintain 0.25 in the meantime. Then advanced, I won't apply any constraint to my dataset geographically. I'll treat negative samples as they are. Okay, then I'll click apply, and my histogram will be displayed. So as you can see from the screen, the y-axis is the number of samples and the x-axis represent the class or the bins, and this is the name that I entered, the gold. The red here, and this is the legend, the red indicating the frequency, and the blue is the cumulative frequency curve. We can go back to the form and change the number of bins that are displayed for the histogram. Remember, initially we selected 20, so 20 bars have been displayed here. Okay, we can go back and change it. The width is 0.25. The greater the width value, the higher or the bigger the bar here. So I can go back by clicking on the icon. Let's say I want to display only 10 bars, so I'll change the number to 10 and I'll click apply. So 10 bars will be displayed here. I can go back, click on the icon and select 20, click apply, and the number of bars will be increased to 20. Alright, so now that we have created a histogram, let's look at some of the things that we can do from this. Okay, we can go to display histogram. You see, all these things are indicated from the two bars here or the two icons. I can go to display histogram so that it will be displayed by the histogram only. I'll click on it and you see the cumulative frequency curve is gone. The same icon is indicated here. I can go back to display cumulative frequency curve, and cumulative frequency curve will be displayed. The same icons are shown here, display histogram, display cumulative frequency. I can display both histogram and the cumulative frequency curve by clicking here. Okay, I can go to display histogram and frequency curve. It's the same thing. Then I can display probability curve for my data set. This is it. Go back to the same icon is indicated here, probability curve. I can also display the normal distribution curve, or go to display normal distribution curve. I can also bring back my histogram and frequency curve with the normal distribution curve. Okay, I can display values for the cumulative frequency curve and the normal distribution curve by going to display or hide graphed values. Let me hide the normal distribution curve. Okay, so these are the cumulative frequency values. All right, I can go back to display. You cannot display an SY scatter diagram because this histogram is drawn from a single population, that is with respect to the gold values only. So you cannot display SY scatter diagram. I can also hide or display the grid that you are seeing here by clicking here, display or hide grid, and the grid will be gone. It's the same thing that you have here. I can bring it back. All right, I can also change the values on the axis by clicking on this icon, axis scale. The minimum and the maximum values represent the minimum gold value and the maximum gold value. You can change the label increment, the distances that you want it to be indicated on the x-axis or the y-axis. Okay, you can also use the view menu to select the axis scale. It's the same thing. You can also go to display. In order to hide the chart legend, you can click on this and it will be disappeared. You can bring it back, or you can click here, display or hide chart legend, and you bring it back. All right, you can also go to statistics, histogram classes, and you can change the number of bins or the width of bins here. As you can see, we have 20 bars displayed. You can change the number of bars or the bins that you want to be displayed. Okay, you can also create a report for your statistics. Again, you can also create a log probability curve, okay, for your distribution of the data set. You can go to transformations, then you select log 10 scale and you click apply, and you go to display probability curve, and this is it. Okay, you can hide the values. All right, as indicated from the chart probability plot. Okay, I can go back to statistics and change the transformations to none so that I come back to my normal histogram curve. Then I go to histogram and cumulative and I have it. Okay, so let's take a look at the next task that we are going to do. If you want to view the gold values, you can go to file, then you select save as, then you choose data file in order to save the gold values that were used to create the histogram. I'll click on that. Let's say okay, the file format, I want it to be a note file. Then I can enter here gold values. Okay, I can enter here gold values. I want Surpac to display the report. I'll click apply, and the gold values on which the statistics was used will be displayed, as you can see here. So these are the gold values. Okay, so it will go into my work directory, gold. These are the values. All right, the next thing that we are going to do is to save the histogram for future reference. The histogram is what we will use to identify if we have bimodal distribution or outliers associated with our data set. So that is of much concern to us. So in order to save the histogram as an image, you go to first display only the histogram, then you go to file, save as, then you select image file. Then is the current chart that you want to save. You can also click the drop down and select all chart, but you can choose the current chart so that it will save the histogram that you have. And the file name, let's say histogram. Then the number of pixels for your image. The higher the pixel value, the higher the image size. Okay, so let's say I will enter 600 by 600 pixels. Then I'll click apply, and the histogram image file will be saved in my work directory. We'll go back and check it. Alright, so I can go into my navigator, and this is the histogram. This is my work directory, basic statistics, and this is the histogram that has been, the histogram image file that has been created. So this is it. Okay, so for future references, you can use the histogram. You display the image of the histogram and use it to identify if you have bimodal distribution or outliers associated with your data set. Okay, we can also create a report for the statistics that you are seeing here. Okay, you can go to statistics, report, and click on it. You can also use this icon here, statistics report. You can click that one here. Okay, it's the same thing. And the output report file name, you can enter any name to suit your reference. I will enter here statistics report. Then the format, I want it to be let's say in a note file, or I can choose a comma separated file that will be in an Excel document. And the percentile, okay, you can enter the percentile so that you can use it to analyze your data for the median, the variance, or let's say the 90th percentile, the 25th percentile, and so on. So these percentiles are according to your preference. I will enter 0 to 90 at intervals of 10 and 95 and 97 and 99 and 100. Okay, so from 0 to 9 at intervals of 10, that is 0, 10, 20, 30, all the way to 90, 90th percentile. I will also have 95th percentile, 97th percentile, the 99th percentile, and the 100th percentile. Alright, I don't want to group data, so I won't check this box. I'll click apply. Okay, so this is my report. The output file name, this is the name that I gave it to it, statistics report. This is the file. The composite inside string file is what we perform the statistics on. The string range, we perform the operation on all the strings. Okay, that is why it has been indicated here, all the strings of the string range. The gold is the variable that we are performing the statistics on. The gold is contained in the first description field. Alright, the number of samples, there are 311 samples. Okay, remember the composite inside file has 311 points, meaning there are 311 samples. This is the minimum value, that is the minimum gold value that we have in our database, and this is the maximum gold value or assay value. Okay, this is the median of our data, and this is the mean, and this is the median. Okay, remember the median is the same as the 50th percentile. So if you look at the percentiles here, we have 0 to 90, 95th percentile. These were the percentiles that we specified. 95th percentile, 97th percentile, the 99th, and the 100th. The median is equal to or is the same as the 50th percentile. So you have 0.36 here and you have 0.36 here. So the median is the same as the 50th percentile. Okay, and this is the mean. We have the variance here and we have the standard deviation. Remember, standard deviation is the square root of the variance, so we can calculate that ourselves. let me search for my calculator. Standard deviation is equal to the square root of the variance. So 0.4, 0.434423, square root of that, and we have 0.6591, and that is indicated for the standard deviation. Standard deviation is the square root of the variance. All right, and we have the frequency. Okay, the frequency here is the count divided by the total number of samples. Remember, this is the total number of samples, 311. The frequency here, the frequency percentage, is the count divided by the number of samples. So if I use my calculator, 127 divided by this 127 divided by the total number of samples, 311, and you have 0.408. that is what is indicated here. 65 divided by 311, you have 0.2090. that is what is indicated here, 0.209. So the frequency percentage is the count divided by the number of samples, and the cumulative count is the sum of the values. Okay, so if you have 127, if you add 127 to 65, you get 192. 127 plus 65, this is equal to 192, and that is what is written here. Okay, so it's the sum of all these, and in the end you come and get the total number of samples, 311. All right, so this is the report for our statistics. Remember, variance is 0.34. variance refers to, or it measures how far a set of data values are spread out, that is from the mean or the expected value. Okay, all right, so this is our histogram, and we have our number of samples, the frequency. This is the gold. Let me bring the cumulative frequency curve. All right, I can also display the okay. So in the next lesson, we will learn how to identify bimodal distribution and outliers using the histogram. All right, so that will be it for this lesson. Don't forget to subscribe to my channel and always look out for these videos. Thank you for watching. Until we meet again, it's goodbye for now.